We probably need the lights on. Now, I call this Soil 101. The original title was My Soil Isn't Any Good. I started in the plant business. Y'all hear me okay?
Yeah.
I started in the plant business. I was a landscaper. And we'd go to people's house and the plants didn't look very good or something wouldn't grow. And it's what I heard all the time was my soil isn't any good. Well, we're on a, that's an idealized, it never looks that good, does it? We're on a river delta here. That's the Nile there. Some of the best farmland in the whole world is on river deltas. And more than likely, you actually have pretty good land wherever you live here. Here in the Rio Grande Valley, you see the farming right up to the river. Yeah, we have very good soil down there. There are a few places where the soil is not too good, but most of our soil down here is very good. It's just, there are things you can do to improve your soil. There's a little bit of chemistry in this. So at the end, there's going to be a quiz. So I'll try and make that part as painless as possible. But basically, just trying to cover some things you can do to make your soil better, make your plants grow better. All right, first, we'll look at a soil profile. All right, that O horizon. This will work. What that is, that's that very top layer, which is mostly decayed plant matter. And then below it, this is what we usually call the topsoil. Now this one says down to about 10 inches. Here in the Rio Grande Valley, especially closer you get to the coast, that topsoil can be several feet deep. We have good land here, for the most part. Now you get further up the valley and you go down a couple of feet, you'll start hitting caliche. That would be that B horizon, but mostly we have an A horizon and that O horizon with the decayed material. And if you ever maybe try this in go to one of the wildlife refuges, land that's never been cleared, and step off the trail, make sure nobody sees you, but just reach down and scratch with your hand, and you can get like this deep. Just that's how loose that A horizon is. It's a wonderful soil here. What is in an idealized soil? This is going to seem wrong, but about half of it, 45%, is the actual minerals, the sand, the silt, the clay. Air spaces. In an undisturbed soil, about 25% of it is air. And again, go to the wildlife refuge or step off along a resaca and land where the ebonies are. You can tell the land has never been cleared there. And it's real loose. And the deal is, when you farm land, the first time they run the machines through there, that land is never going to have the amount of pores that it had originally. But there's a lot of airspace, and I'll get into why you need some air in your soil. All right, water would be about 25% of a soil, and then the organic matter. Let me get into this, but it's usually only about 5%. No matter how much you're going to add, it's going to go back down to about 5%. Okay. Now, what's called soil texture is the relative amounts of the three kinds of particles that make up soil. That's sand, which are the biggest particles, silt are a little smaller, and clay particles are very small. Virtually every soil is going to be a mix of the three. Forget the gravel, we don't have that, but this gives you relative sizes. Oops, I missed it. I was trying to find the pointer. Compare sand, look at the silt particle, much smaller. And clay is, a scale like this, you can't even see it. Clay is very small particles. This is a soil pyramid, they call this, based on the amount of sand, silt, and clay in the soil. They'll give a soil a name. And you see that word loam in there a lot. A loam is a mix of sand, silt, and clay. And then you see something like a sandy loam.
Flesh.
All right, that's a soil that has some of all three particles, but it's a little heavy on the sand. Sandy loam is what always people think, oh, that's the best soil, which probably about as good a soil as there is would be a sandy loam. And around here, if you live on a resaca, it's a sandy clay loam or a silty clay loam usually. If you have a lot on the resaca. And clay soils, we have some on the arroyo in particular, and those salt flats along the coast as you're driving to Padre Island where nothing's growing. Some of those are like 50% or more clay, which is an extremely heavy soil. Some advantages, disadvantages, sandier soils, a lot more air spaces. And the idea is the roots of your plants need to breathe. Ran into a problem. I had a friend that sold he had a bunch of oak trees, and he sold some to a doctor up in Edinburgh. And the doctor put the ring of soil around them, and he just kept them full of water. And the trees started dropping all their leaves, and because he called me after he went to look at them, because he's not a biologist, and he said they're full of water, and he asked me, is that good? I said, no, the roots need oxygen to breathe, just like we do. He says, well, I told the guy, and the guy was there with his son who's taking biology in the 8th grade or something. I said that the roots need oxygen. And he said, no, the roots don't need oxygen. Plants need carbon dioxide. And so that's why he called me. And the problem, the deal is, every living creature needs to breathe oxygen. Okay? We'll get into the green parts of plants use the carbon dioxide. Okay? The rest of that plant, the roots, every other part that's not green needs oxygen. Even they measure it in these enclosed greenhouses up north where nothing comes in, nothing goes out. And the plants are sucking up CO2 all day long and releasing oxygen. So when the sun goes down, if you look at their oxygen measuring deal, the oxygen level is real high. Then you come back in the morning and the oxygen level has gone way, way down because the plants have been breathing that oxygen all night and releasing carbon dioxide again. So you need air spaces in your soil because the roots need oxygen the same way we do. There's that whole deal there. Plants take in carbon dioxide from the air, that's what the leaves do, and water, and they produce oxygen and glucose. I showed this, I'm going to do this kind of ad nauseum here tonight about this right here. The glucose is simple sugar. What the plants do is they take carbon dioxide and water, use energy from the sun, and they make that sugar. And then the plant uses that to make everything else. If you have a watermelon or the bark on the tree, all of that is made originally from that glucose. Oh, there it is right there. This is what you used to dread in biology class. Basically, here's what the roots, everything needs. You take sugar, we breathe oxygen, use a little water, we break it completely apart, and we get the energy out. That's the way that works. You ever get a kid ask you why? They ask you, why do you need to breathe? The simplest explanation, why do we have to breathe, is to get energy out of our food. That's what cyanide does. Cyanide shuts that down, and basically it's like pulling the plug on a machine or something. You're depriving it of energy. You don't have any energy, you croak right away. Back to all right, so sandy soils, you get a lot of air spaces. Clay soils, you want to have some clay in your soil because clay is real sticky. Nutrients and water will stick to clay. This is kind of a tangent, but you can tell when you have quite a bit of clay in the soil, when it gets dry, it'll make cracks. Here's my next picture. Here's why that is. Picture clay is like, or your paper. Just leave it back. Clay particles are like this. They're like sheets of paper, one on top of the other, like this. When there's a lot of water, well, the water moves in between those sheets of clay and they expand like that. Then when it dry for a long time, well, the water slowly leaves and then they go back together and then you get the cracks. And some soils, some clays are worse than others. Some of that soil in those salt flats really expands a whole lot and then it shrinks a whole lot. It used to be the road from Rio Hondo to Laguna Atascosa. There were some spots along there where the road was always trashed out because when they get rain, yeah, it would expand and then then it would dry, and the asphalt was always torn up in little stretches along there because that clay kept swelling and shrinking. Okay, now we'll cover a little bit about the organic matter. As far as that organic matter that's in the soil, well, 10% is fresh, 5% is little creatures that are living in there. Then you have a lot of the organic matter decomposing at any one time. And what humus is stuff that, organic matter that you can't break down anymore. And the rule of thumb is the longer it takes for something like a certain kind of wood or something to decay, the better the humus is going to be. Like that heartwood on a mesquite or something like that might take 100 years to decay, but it makes the best humus. And humus is even better than clay at holding water and nutrients. Okay. Organic matter, one thing about it, it helps keep your soil real loose. You have more air spaces, and the roots in a clay, really heavy clay soil, they have to use up a lot of energy to push through that heavy clay. If you have organic matter worked into the soil and keep it loose, they don't have to expend as much energy doing that. The organic matter also, again, holds the nutrients real tightly, and it feeds all the little soil microbes. Inside, in a soil, let me see if that's cut. I'll get to it in a minute, but you see there's whole ecosystems of organisms in the soil. I used to wonder, because my dad would always pick up like gin trash and stuff like that, and he'd have me out there and my brothers working it into the soil, and we'd get it, gosh, and this deep, it was just this wonderful, beautiful soil. And in a few months, you're back to the old clay soil again. What the hell happened to it? Well, the soil is full of little microbes, and what they do, they take the wood and the bark and all of that, they break it down into, break it down into that sugar. They use oxygen, they turn it into carbon dioxide, which goes up into the air and water. And this process really goes very quickly down here in the subtropical area. The warmer climates, the amount of the organic matter decomposes very, very rapidly. If you were to move to Minnesota, well, when it's cold like that, well, your organic matter is going to stay there a lot longer. You get down here where it's warm, well, it's not going to last long. The old rule of thumb is 18 degrees Fahrenheit, the chemistry in anything doubles. So if you say your soil is 54 degrees, now compare that with a soil that would go up 18, it'd be 72, so it would break down twice as fast. If you got your soil up to 90, another 18 degrees, at 90 degrees, the soil organisms are breaking it down 4 times faster than they would at 54. That wasn't chemists that figured that out. That 18-degree deal, that was the first, the early photographers. They had all those solutions and all, and they had to figure out, well, on a cold day, you got to leave it in this one longer or not as long and all that. But the chemists adopted it, but they didn't think it up. This part here, I'm just going to show you a bunch of organisms, things that live in your soil. Of course, the earthworms. These are some of the larger things you'll see. Now, you can do this. We've done this in school before. You get some soil and you leave it in water for a little while, and then you take an eyedropper and pull that water out, put it on a slide. You see all kinds of little creatures like this. A lot of these are even crustaceans. They're like microscopic shrimp and crabs. And here's kind of a list of a lot of them. Amoebas and flagellates, ciliates. Those first three are single-cell organisms. And then nematodes. Nematodes get a bad rap because there are nematodes that are parasites. My dad used to always treat our citrus with that, but most of the nematodes in the soil don't cause the plants any damage at all. And then fungi, bacteria, actinomycetes, all of these are involved in breaking down any organic matter that's in the soil. Here's a little flagellate. So we have kind of two different ways to go here. You have one or two real long flagella to move you around, or you have a bunch of little short kind of whiskers. That's a ciliate. Get into fungi here. While I'm on fungi, especially in our woodlands around here, fungi are the main things that break down stuff in the soil. And these things here, mycorrhizae. Myco means fungus, and that R-H-I-Z means root. There are fungi that actually live, they burrow into the roots, and it's a win-win situation. What they do is they secrete enzymes that dissolve soil particles, making stuff more readily absorbed, or can be more readily absorbed by the roots. And in return, the plant up at the top produces food and sends it back down to the fungus. And it turns out when I was first starting college, these were like a new thing. They were discovering, hey, there's a mycorrhizae with a certain plant here, a certain one there. Now they realize they're everywhere. And I had a question once. Somebody said, well, I saw on the internet I can buy a bag of mycorrhizae for like $19.95, and they'll send it to me. And I asked the fungi expert at RGV at the time, and he said, no, they're here already. They're here. They're just waiting for, to get active if you put the organic matter down. But, sometimes don't tell anybody at the refuge. Sometimes in Landera, I would grab a handful of soil and take it home and throw it out. I think the mycorrhizae make the plants grow a lot better. There's some around the roots of a little pine. A little bit on soil bacteria. Of course, there's a lot of bacteria doing all kinds of things. But in particular, there's these ones that are called nitrogen-fixing bacteria. You can find these, the clover that's growing in the lawns right now, if you can pull it up with the whole root system intact, and look, and you'll see little bumps on the roots. And what those are bacteria, and they do a lot like the mycorrhizae fungi do. What they do, I think I got the next slide here. 78% of the air is nitrogen gas, about 20% oxygen. But that nitrogen gas is not in a form that the plants can use at all. We can't use it either. You breathe it in, you breathe it right back out. So it's what's called not available. But the plants are surrounded by this nitrogen, but they can't use any of it. What these nitrogen-fixing bacteria do is they take nitrogen gas out of the air and they turn it into ammonia, which we all know dissolves in water. And then there are a second kind of bacteria turns it into this, which is nitrite, and a third one into this nitrate. And this, whenever you see ate or ite in a word, in a chemistry deal, that means there's some oxygen attached to it. That's all that means. If it has ite, it's less oxygen than ate. And you're ready for class now. This is the best form for nitrogen to actually enter into a plant root, is this right here. So what these bacteria do, they take the nitrogen out of the air, turn it into ammonia, others turn it into nitrate, and the nitrate, the plant gets all the nitrogen it needs, and in return it just makes, with photosynthesis, makes food and sends it down and feeds the bacteria. It's a real win-win situation. This is where I'm going to spend most of the time on this presentation, is stuff about plant nutrition. tell you one thing right now, if you don't remember anything else tonight, if your plants aren't growing well, they're probably low on nitrogen. So again, if you doze off or something, I put you to sleep, you got that much out of it. Usually your plants don't have, your soil doesn't have enough nitrogen for your plants. Before we get any further. What this is a list of all of the elements that are in the periodic table you see in a chemistry lab that are in every living cell. Well, this is the plants right here, all of these right here. And most of these are micronutrients, beginning right about here. All these last ones here, those are micronutrients. They need them in very, very small amounts, but they have to have them. You look at your multivitamins and minerals, you'll see a lot of these listed back there too. You've got to have them too. To kind of get a tangent, that's one thing I like about organic fertilizers is their organic fertilizer is made from either plants or animals, plant-animal cells. All of these are there. All of the micronutrients, everything will be there. I'm not sure why I did that. Okay, well. Okay, again, I sort of covered this earlier, but the first thing made by the plants is the glucose, the photosynthesis, and they use that to make everything else. And let's get to this. These are the main nutrients that a plant needs: carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, calcium, iron, magnesium, copper, and zinc. Let me remember that. I learned this in the soil science class. This one is C. Hopkins Cafe, Mighty Good Cuisine. And somebody added, how about animals? Plants don't need iodine. You need iodine for your thyroid gland. You're gonna have that. And plants really don't like sodium much. That's why salty soils. You have to have a lot of sodium. That's part of what makes your nerves work and your muscles work. They won't work without the sodium. It's you think sodium's bad, well, too much sodium can be rough on you, but you have to have it. And the little saying for this one, you just kind of change your inflection a little bit. It's C. Hopkins Cafe, Mighty Good Cuisine, nah. These are the four that are called macronutrients of all of those. Macro means big. These four nutrients are used the greatest amounts. As a matter of fact, about 96% of a plant, the mass is these four elements. It's carbon, hydrogen, oxygen. The carbon and the oxygen you get from photosynthesis. Carbon dioxide, carbon comes from the carbon dioxide from the air. If you breathe on your plant, well, some of that carbon coming out of you will end up in the plant. The hydrogen and oxygen, of course, from water. So those three nutrients you get from, no shortage on those. Now the ones that you're going to have to add to your soil, these are the three main ones: nitrogen, phosphorus, potassium. Farmers, NPK. If you buy a sack of fertilizer, you're going to look and see three numbers there. This is the nitrogen, NPK, nitrogen. This is the phosphorus. Oh, phosphorus, and that's the potassium, NPK. By law, those on a sack of fertilizer, those numbers have to be there. There's another one there. For a lawn fertilizer, you don't need flowers. You got real high nitrogen levels. I like this one, Happy Frog. Those organic fertilizers, you can't get those numbers like we saw. That one of them sack before that had 20, another had 24%. That can't happen. And, organic fertilizer, it's hard to get it over about 7 or 8. That's just the way way it works. And in living things, there's like about 6 to 8 carbon atoms for every nitrogen atom. That's just, so you can't get those really high levels. I did a little work once trying to find out a lot of organic fertilizers, the breakdown of N, P, and K. Of course, bat guano is really high. And blood meal works really well. The other benefit of blood meal, we used to have we plant onions, and at night the cottontail rabbits would trim them off for us. And we couldn't get our onions to grow, so you throw blood meal out there and they'll leave them alone. And then the blood meal is a good fertilizer for your onions. And chicken poop, the white stuff you see on bird poop, that's full of nitrogen. Coffee grounds, I was impressed with that, 7%. Yeah, when I worked at the college, I had my little route. I'd go around and collect the coffee grounds. I think you have to be careful with coffee grounds not to do it too much in one spot, because those tannins in there can be tough. But just maybe sprinkle it out widely, and you'll be okay. And cow poop, it kind of, the chemists, I imagine doing that, analyzing cow poop, but it depends really what their diet is. If they're in a feedlot being fed a high protein stuff, well, their poop's going to have a lot higher nitrogen levels. Why does the plant need nitrogen? Well, you want things to grow, basically. Roots, stems, and leaves, you need nitrogen. And again, I'll harp on this. Usually, if you add nitrogen, it almost always, that's the problem in your soil, and all your plants will stop growing. And some people like to use organic fertilizers. There are advantages and disadvantages. Fish, you could let the fish or something like that, anything that used to be alive, you let it decay, and the organisms in the soil are going to break it down to basically into ammonium. And then that will get turned into nitrate. And that's usually the main form in which the nitrogen enters the root, is in the form of nitrate. This is another important thing if you don't remember anything else. In order for something to go into a plant root, it has to be dissolved in the water in the soil. That's important. You'll see there's the root hairs. On an actively growing root, there's a lot of root hairs. What those do is they give a lot of surface area for stuff to enter into the plant root. But again, in order for anything to enter into that root, it has to be dissolved in this water. Now you need phosphorus for flowers and fruit. You want to get a lot of fruit on a certain tree or something, where you want to go high phosphorus. And you'll see that a lot for African violet fertilizer or something. That second number would be very, very high. You want them to force them to produce a lot of flowers. A lot of times if there's too much nitrogen, they won't flower. They'll just keep growing. The problem with phosphorus is your bones contain phosphorus. Phosphorus, you put it in the soil, and it does it, most of it, and you add, like if you get Peters, the blue fertilizer, you pour that around your plants in your soil, most of the phosphorus there is going to immediately turn into a solid. Now, if it's a solid, it's not dissolved in the soil water, and it can't go into the root. You kind of keep that in mind. That most of the phosphorus you add, again, is immediately going to turn into a solid. That's why sometimes if you're planting something, you might put a little phosphorus fertilizer down at the bottom of the hole, put a little bit of soil on top of that, then the roots can get to it. Because if you throw it on the surface, a lot of it's going to stay there for a long time. It's not going to work its way down into the soil because it's going to turn into a solid immediately. It seems like, well, why even bother? Right? It's not soluble, right? Well, the deal is, I'm going to give you the guy's name. They worked this out. When I say something's not soluble, or a chemist says something is not soluble, what it actually means is like the phosphorus, a little bit of it is dissolved. you take a few teaspoons of fertilizer, throw it into a swimming pool, most of it will stay dissolved. If you throw a ton in there, most of it will be solid. A small amount will always be dissolved. So the way that works, let's try a little scenario, see if this works. This is the water surrounding the plant roots. All right, say that's a chunk of solid phosphate containing phosphorus. That's a phosphate mineral, that piece right there. At any one time, there can be one phosphorus dissolved in this water. One and only one. All right? Here's what happens. That one that's dissolved goes into the plant root. Now there are none. One of these will go ahead and dissolve and replace it. You see? So it's not the idea is that's called shifting equilibrium in chemistry. But there's always a small amount dissolved. As some of it enters the root, well, that allows some more to dissolve into that water. There will always be, say, one phosphate in there all the time. So that phosphorus is going to be slowly available to your plants. But again, you can help yourself out a lot by putting the phosphorus down deeper in the soil where the roots are. Potassium just seems to be, if there's a lot of potassium, the plants just do well. They're just stronger. Kind of a main thing that plants use potassium for is to move water around. In all of nature, there's no living creature other than humans with cars that developed a water pump. There's no such thing there's not like an enzyme in a cell membrane that can grab a water molecule and pump it from one spot to another. What plants do, what you do in your kidneys is what you do is you pump potassium or sodium from one side of a membrane, one compartment to another, and that makes one side real salty and then the water follows it. And that's what potassium is used for a lot in plants, is to make water move from one place to another. Yeah, kind of, I don't know, I have a friend that grows onions. I have a picture later on in here of onion fertilizer, and it's 2100, no potassium in it. I have a friend in La Feria who farms and grows onions. He said they hit them real hard with potassium. Maybe you would know, Mike, you're a farmer, but he said they get a much better yield, bigger onions and all the whole deal. It's a lot better adding the potassium. Of course, the other thing about potassium, the plants will suck virtually all of it up. They'll absorb it all. Because I have a friend that does hay, and they'll hit it with a lot of fertilizer, hit that grass, and it'll grow about this high, and then they'll cut that. They do analysis of that first cut, it's full of potassium, a lot of it. The next cut, when it grows again with no additional fertilizer, the potassium level is a lot lower. Okay. Get away from that. Here are some other macronutrients that the plants need a relatively large amount of. Calcium, magnesium, and sulfur. Now, this is where you can sometimes maybe encounter a snake oil guy down here. If somebody tells you your soil needs calcium, he's trying to sell you something you don't need. Unless you're down in you buy a house or a lot in those bare salt flats down there where there's nothing to grow anyway. Well, you can use the calcium there to knock out the sodium. But somebody's trying to sell you a bunch of gypsum or something, say because you need the calcium in your soil. He's lying to you. Where do these soils come from? Or a river delta, all those limestone hills and the mountains of Mexico, all that limestone, that's little fragments of that got washed down here. That's what formed the soils in there. There's a lot of calcium in our soil down here. There's also a lot of magnesium also. Both of those, again, if somebody's trying to sell you that, they're trying to rip you off. Now, having said that, every now and then, it's fun to throw stuff in the soil. Yeah, like 98 cents, you get a whole deal of Epsom salts. That's magnesium sulfate, and you pour it around on the plants. Now, if you're growing stuff in a pot, it's probably a lot of times potting soils just don't have everything that the plant really needs in the amounts that they need it. But yeah, I always throw a little of that out. It's kind of nice to do. Yeah. Now, a few of the micronutrients, they're needed in very, very small amounts. You'll see iron there. We're going to cover a little bit on iron later. Zinc. My dad would always spray our pecan trees with zinc. Apparently they produce a lot better because they don't get enough zinc out of our soils here. And a guy told me once, and I've been doing it ever since, drive galvanized nails into your trees. That's that zinc, that coating on a galvanized nail, and it will dissolve and get up into the tree. Just put a few nails in there. Now manganese, Cocos plumosa palms seem to need a little extra of that. They'll look bad if they don't have enough manganese. Again, they're needed in very small amounts, but they have to be there. Even they think nickel and vanadium. A guy did a 5-year study with nickel. He grew peat plants in a medium that didn't have any nickel, and planted these seeds. And those peat plants grew, and then he harvested the peas off of those. I guess the original peat seed had some amount of nickel in it, but he had to go about 6 or 7 generations doing this before the plants finally quit growing because they needed that nickel. He was able to finally show that they do need nickel, but there's just a small amount in anything you eat probably. Where does the fertilizer go when you put it down? You might want to keep this in mind. If you buy a commercial fertilizer, 21 something something, and you put it down and you water it in, the soil bacteria and all those little creatures we looked at earlier, they're going to take a lot of it. They're going to soak it up right away. And that's not bad in a way, because that's a reserve that will be slowly released as they die and decay. Or then your plants get that. And some of it sticks to the soil particles, and a lot of it's just going to go down into the drain ditch and out to the bay. And some of that is particularly potassium. A lot of it will actually become part of the clay particles, where it'll be in the clay, but it's going to be stuck in there. It'll never dissolve again, and your plants can't get at it. All right, now the deficiencies down here, usually if your plants aren't growing well, it's either nitrogen or it's iron. Again, maybe with some of the palms it could be manganese, but it's almost always nitrogen or iron. The way to tell nitrogen deficiency, the whole leaf is yellow. The whole thing. Right here. I'm going to do it now. Not there. Oh. One's yellow. Here's the plant at the top there, had plenty of nitrogen. The yellow one was low on nitrogen. And again, that's usually, if your plants are yellow, just start feeding them. Yeah, this is that one I was mentioning. Onion plant fertilizer, just 2100, but if you grow onions, better give them some potassium. All right, now this says water in the fertilizer. Water there is a verb. Okay? I'm not saying there's water in the fertilizer. When you throw your fertilizer down, put the water to it right away. Because actually a friend of mine recently said he was going to buy some fertilizer, maybe it'll rain in a week from now or something. Here's kind of a problem. A lot of the nitrogen in these fertilizers you buy is in the form of ammonium. All right? Here's the deal. You put the fertilizer down. If you don't water it, well, that night there's some dew or a little bit of drizzle, and a lot of it's going to dissolve in that dew or in that drizzle. And here's the problem. The ammonium will stick to soil particles, stick to humus, and here's the problem right here. Get to this slide right here. Here's ammonium. Well, whenever there's ammonium, it's jumping back and forth. Those little ammonium, some of them are going to turn into ammonia, which is a gas. And if you don't water in your fertilizer, a lot of your ammonium is going to turn into ammonia and go up into the air, and the wind's going to blow it right away. So a lot of the fertilizer you put down is just basically gone with the wind. That's why you have to water it in really well.
Should we turn the soil also?
It really depends on how, if you have a real heavy soil, or if it needs turning, you could, yeah. But ammonium dissolves real easily in water, so it should, if your soil is very permeable, it should move on down into your soil. But always water it really well. Now, this is another form of nitrogen fertilizer. Usually you buy a fertilizer, again, it has something ammonium. Urea, notice 46% nitrogen. Yeah, it's really high. They used to have problems with urea because when they would make it in the fertilizer plants, I think they heated it too long, and when two urea molecules join together, they form a substance called biuret, which is toxic to plants. And I had a friend that had a real beautiful Montezuma cypress with a trunk about that big around, and he killed it with the urea. So if you use urea, go real lightly. Really, that's the best way with any time you fertilize. What I like to do is lightly and frequently, as opposed to once a year throw a whole bunch down. Better to do a little at a time. All right, remember that leaf on the for nitrogen deficiency was yellow all over? Check that out. That's what tells you that you have an iron deficiency. The veins are green. In between the veins is yellow. That means you need iron. And that's usually, it takes longer to correct because the iron just doesn't dissolve very well. There's a case of it right there. And you can run into, well, not necessarily snake oil, say, but there's a lot of iron supplements you can buy. And they're effective products, but a lot of them, you spend a lot of money for the amount of iron you get. There's better ways to do it. The idea is there's a lot of iron in our soil here. But that old deal about the iron has to be dissolved in the water, in the soil, to go into the plant. Most of the iron in our soil is a solid form. Those dirt particles and stuff, a lot of them contain iron. Particularly if you have a reddish soil, there's a lot of iron in that. But it's solid. It can't dissolve and go into the plant. So usually, instead of adding iron, what you need to do is make your soil more acid. Acids dissolve things. So if you make your soil a little more acid, even pour vinegar around a tree if you're in a hurry to get something. Any kind of acid will dissolve the iron, and while we're at it, it'll dissolve any zinc, copper, manganese, all those micronutrients you saw earlier. Those will dissolve if your soil is more acidic. This is the old pH scale. I think I have a better one now. Yeah, that one you don't have to turn your phone to see. The idea is, virtually, the only solution that's a pH of 7, right there in the middle, is pure water. Any other solution you encounter is going to be either a little bit acidic or a little bit alkaline, or basic, they'll call it. I don't want to get too heavy into chemistry here, but it has to do with a certain number of water molecules. They're always breaking down to, this is an OH and that. This is what makes something an acid. Let me go back. Is these hydrogen ions, this H+. What they do is they're a little positive little thing, and they want an electron really badly. You get through a lot of chemistry, just know positive sticks to negative. Right? Positive things are looking for electrons, and they will tear up other things to get an electron. That's why the iron dissolves. These hydrogen ions, these H+ in that water in the soil, will break apart those molecules that contain the iron or the zinc or the copper. We used to do that with an egg in school. You put an egg in vinegar, and then it gets pretty pretty much you dissolve it where it's just kind of well, it doesn't crack anymore. And you're dissolving all the calcium in the shell. And that's the same thing going on there. The acid is doing that. Here's kind of what that pH scale is. Let's go back to that. See the numbers, what they mean, or what they are? Here's kind of the deal on that. That's the amount of, say, if you have that concentration of hydrogen ions. Well, it's written like this in scientific notation, 1 times 10 to the negative 4. You see that? Find the decimal point. You go over 4. This one, you go over 5. You go over 7. Now, there was a guy working on making beer. It was in Sweden or Denmark. He got tired. He was measuring the acidity of the beer. He got tired of writing all this stuff out. What he did, that 4 there, he got rid of the 1 times 10 part, and the negative side is just, that's a pH of 4. Here's what's important here. Look, a pH of 5 versus a pH of 4. You think, well, a pH of 4 is a little bit more acidic. Now look at those numbers. A pH of 4 has 10 times as much acid as a pH of 5. So a drop of 1 is 10 times more acidic. So a pH of 5 is 100 times more acid than a pH of 7. And that's what you need. You need the acid to dissolve make things dissolve. Now here's our problem down here. Our soils are mostly a little bit alkaline. They're basic, pH over 7. You can add something to your soil that will make it more acid. Your iron, copper, zinc, all of those things will dissolve more and they will be more available. Kind of getting along, like a short story long here is what I've done. You don't need to go buy something that contains iron. You can just make your soil more acid and the iron that's already there will dissolve and go up into your plants. Let me get to here, right? This is good stuff. This is what you can use. You buy soil sulfur. This is the pure yellow sulfur. They sell it in granules, and they also sell it as a powder. It's also good for dusting your plants. Fungi hate sulfur. You can kind of, like if you have melons or something, you try to control the mildew and stuff, just dust them with sulfur from time to time. You don't have to put any poison on there. You work the sulfur into your soil. Yeah, there's what the granules look like. The going rate was 50 pounds. We used to put 50 pounds for 1,500 square feet. That's what they sell it as 50-pound sacks. Earthwise Organics, the last time I bought some, had a pretty good price on the sulfur. And here's what it does. That's pure sulfur. It's going to combine with water and oxygen in the soil. There's actually a bacteria in the soil waiting for that sulfur to show up. It will take the sulfur, react it with water and oxygen, and make sulfuric acid. You think, oh no, not sulfuric acid, that's a separate battery, that'll burn you. Well, it'll burn you in a car battery because that's 98% sulfuric acid. You're going to have like 0.1% sulfuric acid in your soil. And what it's going to do is it's going to dissolve soil particles and make the iron and all more available. Yeah, there we go. So the sulfuric acid will dissolve soil particles. The nutrients get into the soil solution. Remember, they have to be dissolved in the soil water. There's the name of thiobacillus is the name of that bacteria. You could sound really educated. If you see thio in a word, it means sulfur. If you see that on some medicine, you say, oh, this contains sulfur. And you think, how's that going to know that? And a little bit more here. That was all basically stuff for how you can improve your soil, basically chemically. Usually you need nitrogen. You can add, it's usually best to add a balanced fertilizer. I'll cover some advantages of the commercial fertilizers versus the organics. One thing about the commercial ones is, like say if you're growing a garden, lettuce and things like that, when you add that fertilizer, you put these artificially super high levels of nitrogen and phosphorus and potassium in that soil water, and those plants suck it up and they grow really, really fast. If you try that with a commercial, with an organic fertilizer, that's 7% nitrogen, the bacteria in the soil have to work on that, form that nitrogen in and slowly release it into the soil water. It's much, much slower using an organic fertilizer. A good thing about organic fertilizers, though, is every single micronutrient is there. You're not going to have a shortage of anything. And one disadvantage of commercial fertilizer, you can overdo it. And basically, if you pour too much around your plants, it's like the plant's in salt water. And it'll suck the water right out of your plant. The water's supposed to go from the soil into the root. If you put too much fertilizer down, it's going to go from the root into the soil, and your plants are going to, what they call it, fertilizer burn. You're making your plants basically shrivel up. What you can do, if you like organic fertilizer, this is a suggestion, is get a commercial fertilizer, like something that has a high nitrogen, phosphorus, potassium, for your first application. Put that down, that's going to raise your nitrogen levels and the other levels up pretty high. And then after that, you can stick with your organic fertilizer and just keep adding them. The deal is, they're all going to, either fertilizer, the nitrogen is going to enter the plant as nitrate. So whether it came from a fish head or a sack of little white pellets, that plant can't tell the difference. That nitrate that was formed from either one is identical. There's nothing magic about the nitrogen that comes from an organic versus a commercial fertilizer. Okay, a little bit on soil structural problems. You run into this a lot, particularly a clay soil. You always want to avoid, if you can, working on a clay soil, tilling it, doing anything when it's really wet. You think, how do they make bricks? They get wet soil like clay, and they get it really wet, and down here we'll work the heat here, and it tends to turn kind of like bricks. You always try and work, if you have a lot of clay in your soil, work it when it's pretty dry. The problem there is, you know, buy a new house where they had all those trucks and everything all around it, and they packed that top layer. And there's no air space for your plants to, and they have to expend a lot of energy to get through that. What you can do to improve that structure, get a bunch of sulfur, or you can use gypsum. Gypsum is calcium sulfate. You're not buying, don't ever buy gypsum from some guy who tells you you need calcium. What gypsum does is takes clay soil and makes it loose where it doesn't stick to each other as tightly. I personally, I don't know, I worked this out once, but I may have done the math wrong. I think you get more bang for your buck from sulfur than you do from gypsum, as far as the benefit to your soil. But add that at, again, 50 pounds for like 1,500 square feet. Get as much organic matter, mulch and stuff that you can. Put that on top until your soil as deep as you can. As far as deep as you can get it. And then after that, it should stay pretty loose, and just keep adding organic matter to the top. Hopefully you won't have to till it ever again after that. But keep adding organic matter to the top. And I like to use sulfur once a year on stuff. And if you write this down, here's this liquid sulfur product that we have had really good results with. It works a lot faster than the soil granules or the soil powder. The brand name is Soil-SUL. They sell it in gallon jugs, and you mix it in like a 5-gallon bucket of water, and then you pour it out. Or I used to, I haven't done it in a while, they cut off my irrigation water for a while, but when I irrigate my citrus orchard, I just pour it right into the water coming out of the head. And I get this yellow water flowing through my orchard, and then about 2 weeks later I get the beautiful green flush. But this stuff works faster than the solid sulfur. Now The directions say to put a pint in 5 gallons of water. I think if you have a dog, use a dog food can instead, that's less. I've been doing that for years, that works. I think that you don't need to put a pint in there, but, yeah, it's a very, very good product. I think Grimsel sells it, I'm not sure, but, Valley Garden Center, that's way up in Macau. But that's really good stuff, soil salt. And again, just till it deeply as you can, and then after that, just keep adding organic matter to the top. And good luck, you should have a good soil. Yeah, there's a good idealized view. That's what my garden looks like for maybe a week, and then it fills up with weeds.
What about turning oak leaves and stuff like that into your soil?
Some people don't like oak leaves because of the tannins. So I don't know that, I think you could overdo it with oaks. Seems like what some of the tannins produced by some plants is maybe to reduce competition. Sunflowers will secrete a substance into the soil also that makes it difficult for other plants to grow close to them. You see, like a field that has sunflowers in it, after a number of years, they even start killing themselves off. And I've been told periwinkles do that. Those pretty little pink periwinkles, yeah, they secrete a substance into the soil. And a landscaper told me once that 5 or 6, 7 years of periwinkles in the same place, and then they won't grow there anymore. They basically kind of kill themselves off. But, yeah, I'll open it up for questions if you'll have any.
You said the galvanized nails in the trees, how many, and does it matter
I just
where?
I usually, if I got a crooked galvanized nail, I'm not gonna throw it away. I'll work it in the tree. I really can't tell you how many.
Oh,
I really don't know a dose on that, but yeah, just drive a few in there. They claim it works.
Just about any tree, any kind of tree?
For like citrus or lemon and stuff like that, gypsum, they recommend it
Yeah.
sometimes, or that's where you recommend the sulfur?
Well,
It
yeah,
depends
again,
on the
I
leaf,
may
or-
have done the math wrong, but yeah, I kind of generally use sulfur.
To break down the acids,
Well, it does that too, and it also, yeah, it's gonna make that clay looser.
yes. And produce more fruit at the end.
Well, hopefully.
Because I've used that Miracle Grow, like the blue liquid.
Yeah.
And it did okay, it did spruce it up to start producing some fruit, but then it just kind of calmed down.
That reminds me too, that you can spend a lot of money that you don't need to on fertilizer for plants in your yard, in the soil, as opposed to plants in a pot. They sell all these time-release fertilizers, which you may pay 4 or 5 times as much for the amount of nitrogen that you're getting. Those are formulated and intended to be used in pots where you have potting soil and you don't have all the nutrients and all the microorganisms and all that. But that's kind of a waste of money to throw in your yard, because if you buy just a regular commercial like lawn fertilizer and you throw it out, the microbes in the soil are going to grab most of it anyway and turn it into a time-release fertilizer. So I really don't recommend you spend like $80 on 50 pounds of time-release when you can get the same amount of nitrogen for $20. Because again, it's going to become a time-release. While we're on that, be careful with lawn fertilizers. A lot of lawn fertilizers, grass is a monotype. They have a poison in there that will kill weeds, which are mostly dicots, broadleaf plants. And I've seen people do a lot of damage to their shrubs and trees from using those lawn fertilizers, because they wash into the soil and they get over where your roses and your hibiscus and everything else is, and they start affecting them negatively. So I just avoid
Weeded feet.
yeah, weeded
They call
feeds,
them
and
weeded feet, right?
if you look on the ingredients, the substance that does that usually has AZI or AZO in the name of it. You don't need to know the whole big long name, but look for, if it has AZO, AZI, something like that, that's something that will kill your broadleaf plants. Don't use that, or be careful when you use it. Yeah, because I've seen oak trees and other trees that just look terrible, and that was that was the cause, was they were hitting the weed and feed on the yard real heavy.
So Mike, if you wanted to fertilize or put some of this sulfur down around your citrus trees, is there a time when you're supposed to do it and when you're not supposed to do it?
Well, I used to hear there was arguments even, old timers about, no, you gotta do it in spring, you gotta do it in the winter, this sort of thing. There was a guy at the experiment station back in the 80s. He was originally studying pears and apples, he's from Poland. And they used radioactive nitrogen in these fertilizers when they did these tests. And what they found out from the citrus trees is, doesn't matter when you put it down, they're gonna save it and use it when they're ready. So the only thing, you have to be careful on some plants, if they're kind of plants that are a little tender and cold, if you hit them with fertilizer, say at Christmas, and then they put on a flush of new growth, and then we get 26 degrees in mid-January, well then you'll damage your plants a little. But other than that, they seem to use the fertilizer when they want to use it, and they'll just kind of save it. So,
Okay, so even if a fruit tree has blooms or blossoms on it?
well, that's where you gotta be careful with commercial fertilizers, because if you hit them really hard, too much, again, you're gonna stress the plant, because remember, water's going the wrong direction. Water's the gradient now, water's leaving those blooms and going down to replace the water that went from the roots into the soil. Yeah, you can hurt your trees if you overdo it. That's why I always go really light. Like, say, if we get a little rain next week, 1/4 inch, I'll throw a little fertilizer out in my orchard. And then the next time it's gonna rain good, I'll throw a little bit more out, but I'm never gonna go all in and whole hog and spread several sacks of fertilizer at one time. Just give them a little at a time.
Okay.
I know you mentioned coffee grains, but, eggshells?
Yeah, eggshells have, yeah, the inside of an eggshell is a protein, which has a lot, anything protein, from a plant, from an animal, is high nitrogen. That's why you showed the fish, yeah. And then the outer part is, calcium carbonate. But, yeah, that inner part is got some nitrogen.
And do you need something acidic to break that down or no?
If you add the sulfur, then, get your pH lowered a little bit. And, the deal is, some soils down here are what I call calcareous soils. If you dig and you see little white specks all through your soil, you're never gonna permanently lower that pH. There's just too much alkalinity there. But you can drop it down a little bit. And then it turns out, I used to wonder how you see a plant growing in caliche, how the hell is it doing that? Seems like it should be able to get anything. Well, carbon dioxide, the roots release that into the water of the soil. That combines with water and forms carbonic acid. For a brief period of time, there's a little bit of acid in there that can dissolve a little bit of that caliche, so that stuff can go into the plant. Now plants, the Lord kind of had it all worked out. They have a way of making a little acid if they have to.
They're growing concrete almost.
Oh, yeah, they want to grow in the,
Little crevices.
the cracks in the sidewalk.
So are you the one that sells the native plants?
I do so.
Can you tell us where to go or when to go?
Well,
or-
My
I went to.
wife
we
will
went
not
to-
let me go to this thing without, everybody needs a card, we've got a card.
I'll be the first since I asked.
Thank you.
So what about transplanting some of your natives?
There you
So
go.
when you do it, it doesn't matter?
Some plants transplant really, really easily. Some of them are just, you don't even bother with. We learned that, I was landscaping the house in New Braunfels once, and we were digging up mountain road, which was a complete waste of effort. You couldn't read on the mountain road. Some plants, citrus trees, you can pull one out of, young citrus tree, you can pull it out of the ground, shake it like that, throw all the soil off the roots, and throw it in the garage for a few days, take it out, plant it later, it'll grow. It depends on what plant you're trying to transplant. And when you cut the roots, the plant is gonna lose water through the leaves. So if you're gonna dig up a plant, most of the time, the best thing you can do is pull all the leaves off. Right out. And what we do at the nursery, a lot of times the roots will go out the holes in the bottom of the pot. And we get some of them that are, it's called nailed down, they get nailed down. We will cut those roots a lot of times, that coldest, drizzly, nasty day around Christmas. Yeah, it's 38, and you don't even want to go outside, that's the best day to do that kind of thing. Because you got 100% humidity, there's not much metabolic activity, it's real cold, and a lot of things transplant really easily if you are intrepid enough to go out in the cold. The worst time is like 4th of July, and it's 99 degrees, and there's not a cloud in the sky. That's the worst time you could try to transplant anything. I think I answered your question.
Yeah, just because she had some close to her house and she was moving them, so.
Yeah, again, some plants transplant very, very easily, and some just don't at all. So if you buy mountain laurels, bald and burlap, say somewhere, you get a guarantee. They usually don't have the decency to get sick and die right away. They slowly get sick. The native palm at Sabal is that way also. They don't transplant well. You have to dig a huge ball, but then they don't start looking sick for a while. So you might buy one from some guy on the side of the road, and it's not going to look bad for a month, and then in 2 or 3 months it'll be dead. But when you bought it, it looked pretty good. But you have to be careful. But some of the other palms, like Cocos plumosus, you can basically yank one out of the ground and it will grow. And even small sabals, if I were to save you some grief, I've been there and done this. Little ones growing underneath a big sabal, just gather the seeds and plant them where you want them. If you dig those little ones up, they almost always die. You're better off plant the seeds in your yard somewhere where you're going to have a sabal.
What are your hours?
You want to call ahead of time. Sometimes it's like this down here. But usually I'm around. But
Call
between about 3:45 to 5, I'm usually running kids around. So